Robots. What do you have in mind when I say it? Robocop style? The little cutie ones? Or even just your Roomba vacuum cleaner? Today's topic is robotics and how one artist, Madeline Gannon, makes them approachable and understandable so we can have a more collaborative relationship with them. We will hear about the exciting development in robotics, why industrial robots are Madeline's interest, and how she convinces robots to do things they were never intended to do. As one of the world's 50's most renowned women in robotics, she is the robot whisperer. We are being told to choose between the left and right brain, between studying art and engineering, between creative and analytical thinking. Our society tells us that art and business are not connected. But what if society is wrong? What if it's misleading us? The good news is that understanding what art is can bring us to a new revelation. Art does matter in innovation, technology, and entrepreneurship. And with the help of this podcast and its guests, you as well will learn that art is not an object. Art is a mindset. You are listening to the Artian podcast. With me, Nir Hindi. Hey podcast listeners, thanks again for joining us today. Robots have fascinated us for years. Often, in our best dreams, they are our servants. In our worst dreams, they are our masters. We are excited and afraid of them. But should we? Today's guest, the artist and researcher Madeline Gannon, made the robots her collaborators, her partners. Her work shows that robots can be more than useful. They can be meaningful addition to our everyday lives. She is a 3-time World Economic Forum cultural leader and serves as a council member of the Forum's Global Council of IoT, Robotics and Smart Cities. In addition, she is a research fellow at the Carnegie Mellon Studio for Creative Inquiry. Hey Madeline, welcome.
Hey Nir, it's great to be here. Thank you for having me.
Maybe you can take 1 minute to kind of introduce yourself before we dive deep into all the exciting things you are doing?
Yeah, that sounds great. I'm excited to talk with you today. My name is Madeline Gannon. I have a PhD in computational design from Carnegie Mellon University, where I explored better ways to communicate with machines. So that often meant robots. And I think today we're going to talk a lot about robots, what our future with them is, how we can live together in more desirable ways, and kind of how do we navigate this weird future that is coming at us at light speed to make sure it is inclusive and equitable to everyone.
Great. Madeline, I want to start and ask you, your artistic material is technology and specifically robots. Now, before we get into what you are doing with robotics, I want to ask you, how did you find yourself in the space of robots? Why robots?
Well, yeah, I actually kind of fell backwards into it. So I really started in architecture, not software architecture, not hardware architecture, like building construction architecture. That's my background. And an architect's education is amazing. There's no other discipline that gives you the tools and techniques to dream up something that doesn't exist and convince people to make it real, right? That's all that architects do. And with that, you get a lot of skill sets in how you make new worlds in computers. So 3D modeling, for example. At my university, the last year that I was there, my university got a CNC router. Now, this was in the model shop. So when you build your models that get your ideas out of your head and into the world, a CNC router is a tool that you connect to a computer and it carves away basically a 3D model that you have. So I had never really built anything that wasn't out of paper and sticks prior to that. And this was the first time I could take all my digital creativity that I was learning inside the computer and get something out in the physical world almost instantaneously. And that was intoxicating. I felt empowered that my creativity wasn't hampered by having to rely on someone else to make it. And so that sort of led me down this long path towards doing weird things with this machine, trying to get as much time as possible on it, using it to draw instead of carve, using it to deform instead of, basically what I did was found all the ways I could misuse the tool. And I hit some limits there. And a lot of those limits were from the software, the stuff that talks to the machine to tell it what to do. Because a CNC router is usually made for like cabinet makers to carve, ornate details out of wood doors and bing, bam, boom. And I was asking to do way weirder things. And the software sort of prevented, it was a hard roadblock for me to continue my explorations. And that sort of convinced me to continue my education and learn how to program and how to talk to these machines so I could create my own software that could do whatever weird and random and wonderful thing that I wanted that commercially available software wouldn't abide by. And so that led me, I was doing my master's in architecture in Miami. And so I said goodbye to the beautiful weather and the beaches, and I moved to Pittsburgh to Carnegie Mellon University, where I got robots and programming instead. So it was an interesting trade-off between
totally.
them. And there, the program that I was in had this amazing fabrication facilities with these CNC routers, as well as laser cutters and 3D printers, all these different tools that are basically all the same. They manipulate material in different ways, but you talk to them the same way. And one of the machines that they had there, they had gotten recently. No one really knew how to use it. It was sort of sitting there kind of lonely. And that was an industrial robot arm. And in my studies and learning how to program and communicate with these machines, the abstractions are kind of all the same. So if you can make something that talks to a 3D printer, that's a 3-axis robot. A CNC router is a 2.5. It's a 3-motor robot. A robotic arm just has 6 motors. So there's a little bit more complexity, but it's basically the same thing. You feed this machine geometry in just the right way, and it can come to life. And so that's sort of how I like kind of wandered into robotics just by happenstance, because I was playing around with a machine in Miami, doing things I wasn't supposed to do with it.
Yeah, it's a characteristic that we will go back to. I often see it among artists. So a question to our listeners: when you already probably understood that Madeline doesn't work with regular robots. Normally when I ask you robot, what do you think about? Often people think about the Robocop style or this cutie small one. But the robots that Madeline is working with are the industrial, the huge one. We will add to our show notes a video how she interacts with one of these huge industrial arms. And Madeline, what I'm interested is that industrial robots are designed mainly for human labor, taking heavy stuff from one part to the other, and they are designed in a way to just execute a specific task. Why change it?
Well, I mean, that's a good question, right? And so industrial robots, they're actually a really old technology within the context of robotics. So they're kind of one of the first robots ever made and brought out of a lab and into a work environment. And it sort of came on to the factory line in the 70s. That's like dinosaur compared to all the other robots that are coming to life now. And they're really great. And they're very great at automation. It's a complicated topic. They kind of replace human labor, but they also do things that is dangerous for people or that people just can't physically do. So these machines, what I love about them out of all the robots, and I love lots of robots, but what I love most about industrial robots is that they have superhuman power. They're superhumans, They're Superman. And they can move at, the one that I was working with, it weighs 1 ton, moves 7 meters per second. It can hold 300 kilograms to a millimeter precision in perpetuity. These are the things that we describe our superheroes with. And so for me, if I could just take that thing that was designed to do short, repetitive tasks over and over again forever and just open it up a little bit so that I could take some of its superpowers. That's really what I'm always going after. That's really what I'm always chasing, is how can I have the superpowers of this machine? And the way I see that is oftentimes it's just a software, it's an interface issue, right? If I could communicate with this machine a bit more intuitively, if it could anticipate what I'm doing and what I need, now all of a sudden we're working, we're collaborating, we're kind of connected in a more natural way that I can take some of those superpowers for myself.
You talk about this, it sounds so compelling. It's like at the end, you think about a robot and you describe it in such a compelling and, I don't know, relationship, humanistic relationship in a way. Which one of the things that also it's interesting is that you want to bring these machines from the factories into our live environment. Why? Why do we need a robot that can hold 300 kilograms into the regular environment of humans?
Well, I mean, there's certain environments that, like, maybe you don't need a robot that picks up a car chassis in an assembly line. Maybe you don't need that in your kitchen, So there's some context for that. But, that would be really, really, really wonderful to have on a construction site. Because now you have this really adaptable machine that can be a forklift. It can be a cherry picker, a scissor lift. It can hold something instead of using expensive formwork or a material intensive formwork. It can just hold it forever while, say like you want to cast some concrete and you need to hold something in place. It can just hold it there. It's not going to get tired. The flexibility and adaptability of this machine is why it's been so helpful in manufacturing, in automation. And if we could just have more intelligent software, give the robots a bit more contextual awareness of what's going on, now all of a sudden it opens it up to a lot of more applications and a lot of more domains. The other aspect of this is that these robots are also kind of symbolic of a lot of the newer machines that are coming out into the world. So if you think of a self-driving car and you think of a robotic arm, they don't look a lot alike. But in both scenarios, you have something that moves very fast, is very heavy, is very dangerous, also very useful, and that doesn't look like us, and that doesn't have a good way of communicating with us, and that is impacting our lives and sort of joining us in a public environment. And so the robotic arms are a more stable, older, more mature technology platform to begin to explore the fuzzy edges of our future with these machines as they kind of live among us.
You're talking and I'm getting excited. And I have so many questions, Madeline. You walk the walk, no?
Yeah. I mean, I try to.
So now, I don't know, listeners, if you listen, there are some noises in the background. It's because Madeline now not only tell us to put robots in construction site, she is actually building her new home to live with the robots.
Yes.
Maybe we can share.
We're having a conversation from a construction site at the moment. Yes. And so the story of how that came to be is did my PhD. I finished my PhD, and a lot of the work that I had done had been, because when you do academic research, it needs to fit within a certain confine. It has to check certain boxes as you do it to get the degree. And then now that I'm done with that, I just sort of step back and say, wait a second, I can do anything. What do I want to do? What's the next step? How do we take this to the next level? And for me, it wasn't just, inventing better ways to communicate with these machines, but I wanted to explore how to cohabitate with them. That's the future that's arriving. The self-driving cars, the delivery robots, the logistics robots, the robots that we see in hospitals, the robots that we see, cleaning floors. These machines are here. They're actually here in our lives. And a lot of them are not quite, the future that we hoped for, the future that we signed up for. And so what I decided to do is actually commit to that idea of living in the future and beginning to work out what is the new normal going to be in 10 to 15 years with these machines. And you can't do that when you go visit your robots in an office, from 9 o'clock in the morning to 5 o'clock at night. You need to live among them. They need to live among you. And so that's what I've committed to. And that's what we've been working for the last year. And we're close. We're really, really close to being done with this project and beginning to move in with myself, my husband, our 1-year-old daughter, and a whole menagerie of machines for her to grow up around.
You're saying things that kind of speak to my heart. One of the things that I've noticed, and I always work in the world of entrepreneurship and business, I always say that business, especially business, in order to get better, they need to look to the past in a way, in improve it.
Yes.
Artists always look to the future and try to create it. And I feel that in this space, there is a lot of room for collaboration and mutual learning. And the fact that you are saying this is a future of 10, 15 years, but you're already creating it today. I always find it fascinating why artists actually doing it, why they take it upon themselves to create these potential futures that often we discuss, but artists live.
Yeah, I think we have a lot of permission from society to be weird, to be abnormal, to really push at the limits, right? So I think that that's part of it. I think also artists are, especially when you work in technology and you're trying to push at the edge of the future of that technology, they're competing against corporations that have R&D departments of 30, 40, 50 people working on some of these things. And so to be competitive in that space, you have to go further out. You have to go in and sort of wander and scout terrains that aren't immediately applicable or relevant to corporations that maybe are looking at a 3 to 5 year timescale, right? You have to go further out, 10 to 15 years. And if you have a good nose that can kind of sort of like smell and tell the direction of where things are going, if you keep your eyes open along the way, then all of a sudden you find yourself in really relevant terrain in that time scale. So is everyone going to be living with next to like robot arms on their desk next to the...
You cannot see it. Maybe I will post the picture after. Madeline just showing us now the environment she built, and there's already a robotic arm over there with her new 3D printer.
Right. So maybe, that's not everyone's reality in 10 to 15 years, but like you can begin to abstract this to very, very normal things. Like, for example, standing desks. Standing desks are very dumb robots that people have in their everyday lives. Now, when that standing desk can talk to your window blinds, can talk to the doors or the shades, or, when those things become connected and more integral into a articulated environment, now all of a sudden you're getting towards that more robotic future that is maybe 10 to 15 years out.
I want to ask you a question. A few weeks ago, I spoke with Jim McKelvey, who is a well-known entrepreneur, but he's also a glass artist. And we discussed one characteristic that he thinks that only entrepreneurs and artists have in common. It's audacity. And you already started to speak about it, that going into this 10, 15 years future. And when we spoke in the past, you said, my goal is to do something nobody did. And I'm asking why or where does it come from, this desire? Or aren't you scared to go to places that nobody's been before?
I mean, I guess maybe I just have the characteristics of an explorer. For me, it's like, why would you do something if someone else can do it? That for me is the hard stop. Is like, there's a lot of folks that are doing really, really beautiful, interesting work, highly technical work, doing like filmmaking with high-speed robotics. And I'm so enamored with it. And like, I have all the tools to do it and to do it kind of in an interesting way. But I feel like, for example, there are people doing that. And so, okay, that terrain has been scouted and it's been mapped out and there's a paved road for people to go there. For me, I want to take the machete and start like cutting through the jungle to see where the new worlds are that may or may not even be interesting. If you're an entrepreneur, if you're a researcher, if you're an artist, what you really are is an explorer. And when you find new land, oftentimes you don't want to now create a town. You want to pass it off to someone else and go find another new place. It's just this constant curiosity, at least for me, is what drives me to go further out.
By the way, we didn't talk about it, Madeline, but that's exactly also what Jim McKelvey said. He says artists and entrepreneurs are explorers and the rest are tourists. They have a map and, they just follow the map. Artists and entrepreneurs go exactly as you describe it. Very interesting. And you haven't talked yet. So I want to kind of ask you another question about one of your work. But before that, let's take a short break.
Hi, listeners. It's clear that our speakers are at the intersection of art and innovation. But they didn't just arrive there casually. They developed their skills, gained knowledge, and more importantly, grew their artistic mindset. Would you like to develop some of these skills, capabilities, or a growth mindset? then I would encourage you to check our art-based learning experiences. Whether you want to build your leadership skills or your innovation competencies, our training can be just what you are looking for. Visit us at www.theartian.com. That is TheArtian.com to learn more.
Hey, thanks for coming back. We are speaking with Madeline about industrial robotics and the future of co-living together.
We are living in a golden age of robotics, where the past 50 years of promises and potential are finally coming to fruition. And robots are leaving the lab to live in the wild with us.
Madeline, one of your works, it's called Manus. It's a group of robots, maybe, I don't know, in the video I saw 15 or 20, standing a kind of a row, long row, and they interact with human. Now, these robots, a group of one-arm robot with kind of an eye that looked at us, and like other works you are doing, there is an element of randomness. In a way, I can imagine myself looking at all those 20 one-eye robot arm looking at me, and knowing that they are random, which means they don't do what I tell them, kind of can reinforce the fear of human of robots. Because you add this randomness to robots to do what they want. First of all, why you add this randomness to this work with robots?
Well, I wouldn't necessarily call it randomness. I would call it autonomy. For us, is perceived like random, but they have their own agenda. They're programmed to kind of do what they want, respond to their environment, but really with this idea of autonomy. And that project in particular was an invitation from the World Economic Forum to help the visitors for the annual meeting begin to think about what our future with these machines could be for the fourth industrial revolution. So as an artist, I saw it as an amazing opportunity to put something in front of policymakers, the people who are actually going to impact how this technology enters into society across the world, and get them to think about ways that this technology could be rather than continuing on the path that we have now. So the idea of autonomy is really what we're working towards, both inside and outside of industrial manufacturing. These machines are getting smarter. They're getting more aware of their environment. And as a consequence, they're able to make decisions without us explicitly telling them to do something. And that can be a great thing. It can also be a scary thing. The idea is to highlight both. With a lot of the work that I do with these machines, I try to tell people and show people that they're not pieces of manufacturing equipment. They're actually creatures. When something has autonomy, it behaves without us telling it to do something, just like any other animal or person that we interact with on a daily basis. And you and I, there's social norms, there's cues that we have that let us cohabitate and interact in a pleasant way, in a productive way. And what I've been working towards is trying to find those same cues and show that we can transcribe those same cues onto these machines that look nothing like us, and we can still respond to them in that same way that you and I, even through a video call, our body language is still resonating with one another.
Do you think we should be afraid from robots?
I don't think that matters. I don't think my opinion on that matters, whether we should be afraid or fear of it. I mean, I'm in a privileged position to be working in this field.
You speak about the robots like they are cats. It's like they're sweet, like autonomy. They have their own autonomy. And when I see you this video that you did a lot of this with this huge arm, it's like we are so small compared to these robots.
Yeah. That's also why I like working with industrial robots, because they're these massive beasts of machines that, it's very evocative to be, and you feel like a lion tamer. So does everyone need to be a lion tamer? No, but it's kind of fun to do it, right? What I'm interested in is not should we or shouldn't we be afraid of these machines, but it's really take this technology that is kind of found in industry, it's found in academia, but it's not really found in culture. We sort of made up our minds as a society that we don't want these machines to be our overlords. We don't want them to be our slaves. We don't want to be their slaves either.
Yeah.
You know, that there's consensus across humanity for that. But what we haven't decided is how do we want these machines to make our lives better, to augment and expand and enhance our daily experience of life. So that's why I like to work with policymakers, to work in cultural institutions, sort of take these ideas out from a handful of people who know how to use this technology and bring it to wider audiences so they can start to build an awareness of what this technology can and can't do, but also begin to grapple and chew through and make up their own opinions about what this could be or what they might like about it or what they're very distrustful of. I think that that's really the most important thing.
Yeah, asking questions and not just accepting as the reality as is. One of the things that positive listeners can hear in your voice is that you are speaking about it in a very positive and optimistic way. And I have a very good friend that always says that we always tend to show the negative aspect of technology instead of speaking about the positive influence of technology. And why you feel compelled to look at that and to make us maybe look at the robots in a more positive or optimistic ways? Because just last month, the World Economic Forum published their Future of Jobs 2025. And in it, they say that, I don't remember now the number, 50%, 60% will be replaced by robots. So a lot of people, it's also kind of a concern for their livelihood. But still you maintain this optimistic and positive. What will you tell them?
I think their concerns are valid. I think their concerns are just as well. I think not only with robots, but also software, right? Automation that's happening in software. The reason why I have optimism is because I focus on the future. That's the way that my brain is wired. Focusing on the past, focusing on the present, they are the fuel, at least for me, that helps me burn the light that looks towards the future. And for everyday people, automation, robotic automation is having an immense impact on their daily life in the present, especially in Asia. In China has adopted robotic automation at a higher rate than the entire globe put together, right? So they're going to begin to feel that in their labor market as well. So there are folks that are working on equitable policies for integrating automation into the workforce and different type of economic structures and social structures and safety nets to help ease a transition towards your value in society not being directly linked to the time and labor that you put in during the week. What I'm trying to do is chart out new paths forwards, new metaphors, new frameworks for using this amazing technology. So we didn't have to, automation was not an inevitability with this technology. In the 60s, when these machines were just coming online in General Motors, in other manufacturing contexts, at the same time, there were artists and computer scientists building these machines that actually had personalities and that responded and reacted to people, that had curiosity, that had creativity in mind. And what happened was that the economics of automation won out over the economics of companionship and curiosity and creativity for these machines. So I feel like for me, the gauntlet that I try to bring towards the future is sort of picking up what was left off in the 60s and sort of exploring if now's the time and that we can actually revisit those ideas and make them a reality.
Do you have some recommendations for which artists we should check from the 60s?
So there's this amazing exhibition that happened in England called Cybernetic Serendipity.
When one goes to an art exhibition or an exhibition which involves poetry and music, we think that the people who have composed the music or who have produced the images or who have written the poetry are artists or poets or composers. In this exhibition, this is not true.
there's a treasure trove of amazing work there that really got to the heart of just crazy people exploring what this new technology could do. And what it can mean to us. A lot of it goes towards representation, so people drawing or painting, carving with machines. But a lot of it also was like actually trying to make mechanical life. And like that was amazing. And they did it like they didn't have computers really then. Like the computer was such an odd concept. It was like with like hydraulic pumps and it was just like I have no idea how they did what they did, because like I could recreate it now with all the tools that I have. The amount of innovation and ingenuity that went in to bring these creatures to life was really, really spectacular. One of my favorite artists is a Dutch guy named Edward Inakowitz, and he had this sound activated mobile Sam that was this creature that would listen for you and reorient its like really ornate vertebrae spine and its face to look at you as you are around it. And, if you look at that work and you look at my work, there's like a direct line between just the kind of interaction and engagement. And that to me is really what a lot of what I explore in my work is that, what the robot is doing is it's giving you its attention. And that is, especially in this day and age, giving someone your attention is such an act of generosity. And even when a machine gives it to us, we sort of feel a connection to it because of that generous act. And so that's a single dimension of exploration that I've been digging into with our relationship to these machines. And there's so many more dimensions that people that come from different backgrounds, different value sets, different worldviews, different disciplines could begin to layer and explore into our future with these machines if the technology were more open and accessible and relatable to those people.
If I may add to your last comment, I think if people will be open-minded to these technologies and not scared from them, I think we can have much more collaborative opportunities as you just speak about. Because listening to you it raises a lot of kind of questions, why we perceive the robotics world as we perceive.
Yeah, I want to reiterate that those fears are valid. When you're working manufacturing and the plant starts to integrate robots, it's a scary feeling and it happens, right? But there's a shift now that needs to accelerate towards those rather than, and Tesla kind of admitted to this with their factory as well, that working with robots plus people was more effective, more powerful than just doing robotics or just doing people. So to find those points of engagement where robots plus people can be greater than the sum of their parts, I think is really wonderful, right? You use the robot what the robot's good for, you use the person for what the person's good for, and you build the interface, the software that connects them into this more integral system.
Great. So that's led me to my next question, because you spoke about innovation, you spoke about creativity, and you spoke about creating this software, and you actually created one. And in your work, there is a kind of potential for innovation that I see. Your robots respond directly to human action instead of the typed commands most robots rely on. So instead of pre-programmed commands that probably are very good for more secure or more repetitive work environment, in yours, it's very difficult to kind of pre-program because the robot itself needs to thrive in a dynamic environment. Something happened, they respond. So you developed the Quipt, a control software for robots that acts as an interpreter translating human motions into instructions for the robots. Tell us about this Quipt.
It basically helps a robot understand our body language, and it responds with its own body language. And what's really wonderful about that, we have verbal communication, we have written communication, but nonverbal cues, nonverbal communication is something that is broadcast at such a primal, low-level frequency across people, across species, that it's something that we can't turn off. And so it doesn't have high fidelity. I can't do body language and communicate the same way that if I were to just tell you a sentence, right? But at a low level, for low level states of mind, it's an amazing transport for that information. And just as an example, like if you have any pets, if you have a dog or if you have a cat, you know that if its ears are back, it's kind of feels threatened. If its tail's between its leg, it feels threatened. If its tail's wagging, it's happy, right? These kind of nonverbal cues that it knows that, when you sort of make a certain face and sort of tower over it, that it's done something wrong and probably shouldn't have eaten the garbage out of the can. Like there's certain things that we just know when we coexist with different species that makes it a really enjoyable and meaningful relationship across these two things. So with robots, and that's a lot of what I've been working towards, is building this kind of repertoire of body language and ways of having it be in a flow, just like we have with other living things. So for Quipt in particular, is really I was really fortunate to be in an artist residency at the software company Autodesk. They had this amazing facility called Pier 9 that was just chock full of CNC machines and robots. And it was like being in a candy store for me. It was amazing. And so they had this big 1-ton robot, an ABB IRB 6700 that again it was just sitting there. They didn't really know what to do with it. And they also had this motion capture system, which are cameras that can sense three-dimensional space. And so if you've ever seen on a film set where they make actors wear these suits with little dots on them, it's the same technology. And so for me, I saw here I have a robot that can move in the world but can't see. And here I have cameras that can see but not move. Why don't I just build some software to connect the two?
Amazing.
And by making that and by having that kind of continuous fluid feedback interaction between how I was moving and the robot responded, it sort of became apparent, as much as I was impacting the robot, how it moved, how it was moving was also impacting me. I wasn't expecting to feel a connection or to feel an emotional response to how the robot was moving. But lo and behold, as soon as you make something move in an animate way, that response is attentive to you, that we as humans sort of project our own emotion onto it. And we can't help it. It's kind of hardwired into our primal monkey brains.
What did you feel the moment you saw this connection?
Yeah, it felt like I had a little puppy in the lab that was just really happy to see me. As I was programming it, sometimes it would be very, very jittery and move around, and that kind of seemed like it was excited. It also made certain motors move, which have a higher pitch sound or a lower pitch sound. So it's like a multi-sensorial experience where it's not just kind of the spatial interaction that you have, but you can also hear the sound, and you're not supposed to touch them, but also there's a little bit of tactile interaction too.
I wouldn't call it a puppy, more of an elephant height or giraffe height. That's how tall is this
a big puppy. Big puppy.
Something like that. You mentioned this artist in residence, and I wonder, you worked with few companies. How is this experience working with companies? Why actually you want to work with them? Why they want to work with you?
What I get out of it, a lot of what I get out of it is access to expensive equipment or space. And what they get out of it are a prototype of their future users, at least in the case of Autodesk, right? So for their artists in residence, they brought in a group of people who are doing really advanced things that oftentimes don't even use their software because their software caters to the masses. It has to, economically, it has to cater to what most people want. And so here are these fringe people doing fringe weird things that get them sort of they just plants little flags to see is this actually an interesting direction to go to? What sort of innovations are have? What are the limits of our tools? What's the low-hanging fruit to sort of build as features? And what is would need a total overhaul for it? So I think at the end of the day, I hope that it's, a win-win-win situation where I get something out of it, they get something out of it, and us together get something that we couldn't get apart. It's not purely transactional. But I think that, at least in the case with Autodesk, that they got the better deal. I got some access to equipment, but the several cohorts that they've done, they've been able to actually hire a lot of these interesting people as well. So that's great for talent acquisition. They've been able to have basically affordable consulting on and feedback from advanced users for what their current software can and can't do.
Yeah,
and they've been able to get a sneak peek of what's coming in the future.
One of the things you mentioned when I asked you about artists in residence is that you want to move the needle, how the technology of those companies actually can be more human. Why you feel you want to do it, and how they respond to this desire of yours to make technology more humane?
A lot of principles in human-centered design
exactly
is still sort of like design thinking is something that has sort of traversed from design school into the design discipline over into industry. And human-centered design is not quite there yet, right? So if you have a project manager developing software, perhaps they've done some design thinking training on it. But human-centered design is something that still hasn't sort of risen to popular enough frame of thought to sort of carry over into these new disciplines. And I just find it very, very powerful way of thinking about these things that is basically like, for a lot of things, is like, don't make software that needs a tutorial, right? If it's not intuitive enough for people to just play with and pick up, then you're doing it wrong.
Beautiful.
Like,
great advice.
Yeah, exactly. So that's kind of one aspect of it. And I think at the end of the day, the goal isn't to make technology more human. The goal is to make technology more relatable, more relevant, and more empowering at the end of the day, right? So it's not like especially in robotics, I think it's sort of the opposite. You don't want to make the robots more human. You don't want to make the robots look like us. What you want to do is make them more relatable, more legible, that people intuitively understand what they're doing without looking at a screen, without reading a manual.
I always say that art is made by human for human. So art by nature is human-centric. And you just said it, I think you nailed it when you say it hasn't become yet a way of thought or way of thinking. And that's what I feel. I feel that, design thinking and lean startup and maybe agile development, those are great methods, but it's not yet the mindset that you would like to see. Because everyone has access to those tools, but still you don't see a lot of innovation or a lot of human-centric design results in that sense. So it's very interesting. We're getting into the end of the podcast, and I definitely can continue this podcast for another 2 hours. I don't know, you probably have your own day. But I want to kind of ask you maybe one or two final questions. What is the most exciting advancement you see today in robotics?
I mean, hands down, it is the amazing developments that are happening in machine learning and artificial intelligence. And basically, what has been pretty reliable and pretty useful. So let me step back for a second and say, like, artificial intelligence is also this really scary term for a lot of people. And a lot of it is hype. A lot of it is, I think, a bit overblown. But what machine learning and artificial intelligence can do really, really well is look at a lot of data. And when you see something new, it can build a bridge from what you have seen to what you're seeing right now. And what that means for robotics is that you don't need to program every possible instance and scenario for that robot to do something, which now, if something new happens in front of a robot and it doesn't know what to do, it crashes, right? So there's no possible way that if these robots are going to be truly autonomous, that I can enumerate all the possible scenarios that could possibly happen to this robot across its life for it to successfully exist. And so machine learning is sort of bridging that gap between old knowledge and new knowledge for these machines. What it also does is it makes working with cheaper sensors, cheaper equipment, a lot better. So something that you would need like a $10,000 sensor for a robot to be able to do a task accurately. Now all of a sudden you can do it with a webcam, or you can do it with your phone, because machine learning is there to sort of fill in the blank spots of that data set. So that to me is really, really exciting, because what it means is that this technology is no longer limited to the people who can afford, $1 million labs. It's really coming down to if you're a kid in high school and doing a science fair project, that you have an opportunity to be really innovative. You have an opportunity to make a discovery that makes impact. That to me is really, really exciting.
One last question. You said in past interview, the robots connect with us in a meaningful way. That is the future I want to live in. Describe me this future. 15 years from now, how it will look.
That's a good question. I mean, to be honest, I don't really know, right? So part of being an explorer is not quite knowing where you sort of have a heading, but you don't have a finish line, right? So part of what I'm setting off to do is find out what that 10, 15 years looks like and report back to the rest of the world what that is.
Great. I love it. Madeline, I don't know about you. Probably the listeners know that already I enjoyed. I hope you enjoyed as well.
Very much.
You are very kind, and I envy the robots that they spend so much time with you. So,
it's a good company.
Thank you very, very much for taking the time and sharing all your great work. I will highly recommend you guys, the listeners, check Madeline's work. We will have on our show notes all the links for things she mentioned. Madeline, thanks again.
Thank you.
Have a great day back in Pennsylvania. We are producing our podcast without any ads, and we are relying on our community's direct support. People like you, our listeners. So if you find it valuable, I will be super grateful if you could spread the word by leaving a rating and maybe a review. It will take you just 30 seconds to do so, and it is very helpful in getting these ideas to a wider audience. If you are interested to develop your artistic mindset, if you are looking to grow your business, if you want to develop the innovation competencies in your organizations, I will highly recommend you to check our workshops and trainings, all available on our website. The episode was mixed and mastered by Daniel Duran. You can subscribe to the Artian podcast on Spotify, Apple Podcast, Stitcher, or wherever you get your podcasts. Our previous shows are available on our website, www.theartian.com/podcast. Each episode includes show notes, guest recommendations, videos, and other materials. We can also be found on our LinkedIn page, Instagram, Facebook, and Twitter. And you can reach us directly via email at podcast@theartian.com. So I will be waiting here for you in the next episode with me, Nir Hindi. Once again, thanks for listening.